Alright, well, good morning, good afternoon, good evening, whenever you're watching the videos. That's the nice thing about the videos, you can watch them at any time. So, we're going to do section 6.2 today. We're going to talk about factoring trinomials of the form ax squared plus bx plus c. And we're actually going to talk about specifically when a is 1. So we're going to talk about specifically, hang on one second, there we go, when a is 1, especially for this section. When a is equal to 1, that's what we're talking about in 6.2. When a is not equal to 1, we'll take a look at in 6.3. But right now, we're going to talk about when a is equal to 1. We're going to talk about factoring this. So we're going to talk about factoring because actually in chapter 5, we talked about taking two factors and multiplying them together to get a product, something like 2 times 3 equals 6. 2 and 3 are factors, 6 is the product. So in chapter 5 we talked about using this idea to get a product of 6. We took the factor and a factor, multiplied the factors together and got a product. It would, I guess it would have been something like x plus 1 times x plus 2 would equal x squared plus 3x plus 2. Chapter 5 would talk about this, multiplying this factor and this factor together to get a product. Here's our product. So now, with chapter 6, we're actually going to start with something like this. We'll be given something like that, and we will have to factor it to get our, in other words, we'll have to factor this polynomial to get our two factors. So that's what we're going to do here, is factoring trinomials. And really, yeah, all this stuff is factoring. Is like doing multiplication backwards, which we're kind of doing. So if I was over here using numbers, I would say here's 2 times 3 are the factors, and the product is 6. If I give you the product, what are the factors? Oh, the factors are 2 times 3. So we're going to do this, 6 over to 2 times 3 in chapter 6. All right, so let's take a look at maybe a pattern and see if we can maybe see what goes on here. If I've got x plus 3 times x plus 7, we multiply it out, we use the FOIL method, we got x squared plus 3x plus 7x plus 21 equals x squared plus 10x plus 21. And I did this for a couple different examples here. X plus 3, x minus 7, x minus 3, x plus 7, x minus 3, x minus 7. And we just found a couple different things that really just change. If we follow the pattern, you can pause the video and kind of take a look at the pattern, because essentially what we're doing is multiplying, foiling this and getting 4 terms, and then adding up the 2 middle terms, the like terms, to get this term here. So what happens when we take a look at the coefficient here on our x term, and the number here, the coefficient here on the x to the 0th power term, or just the coefficient, the number here? We can see kind of a pattern that 10 here is 3 plus 7, and 21 is 3 times 7. Negative 4 is positive 3 plus a negative 7, and negative 21 is 3 times negative 7. And the same holds true for this, same holds true for this. This number here, the coefficient, is the sum of these two numbers. This number here, positive 21, is the product of these two numbers. So that's really kind of what's summarized here. Coefficient 10 right here is 3 plus 7. The last term, 21, is the product of 3 and 7. So really, when we have a product that's ax squared plus bx plus c, and oh, by the way, for this chapter, for this section only, we're going to talk about a is equal to 1. So when a is equal to 1, this holds true. When we need to find the factors, we need to find the two numbers whose product is c, and whose sum is b, and that will give us the two product, or that will help us find the two products. And keep in mind that this holds true only when a is equal to 1. A is equal to 1. That's a 1, by the way. If a is equal to 1, then this holds true. So let's do some examples and see what we can find. All right. So now, this slide kind of tells you how to make your life easy. This is kind of the make your life easy. And I don't know why this does this. Sometimes it changes to purple instead of blue. This is make your life easy. And I would recommend maybe modifying these recommendations and saying this is number 1, this is number 2, and this is number 3. I tried to modify the slide, but the slide wouldn't really modify easily enough to change these 1, 2, and 3s. So I'm going to say, maybe just call an audible here and say, step number 1, write the trinomial in descending order, ax squared plus bx plus c. Remember, descending order talks about the power on the exponent. Descending order says, well, this term has an ax squared, so the squared is 2, the power is 2, the power here is 1, the power here is actually, it's unwritten, but it's x to the 0th power, because remember, x to the 0th power is 1. So now we've got things in descending order here. X squared, 2 is bigger than 1, is bigger than 0. This should be a 0. And that's descending order. So step number 1, write the trinomial in descending order, because we will be always given trinomials. So write the trinomial in descending order. Step number 2 is factor out any factor that's common to all terms. And that just makes your life easier, because then you can work with smaller numbers. And this will hold true for the next section as well, so it's probably a good idea to remember these as well. So write the trinomial in descending order, factor out a factor that's common to all terms. That makes your life easier, because then you can work with smaller numbers inside that ax squared plus bx plus c. And then if the leading term, this ax squared, if that a includes a negative number, in other words, if that's a negative 1 x squared, or if it's a negative 15 x squared or something like that, then you can just factor out a negative 1 to make your life just that much easier. It's doable if you don't factor out the negative 1, but factoring out the negative 1 just makes it a lot easier. Alright, so now after these steps here, 1, 2, and 3 in modified order, 1, 2, and 3, now that we remove the common factors and the factor of negative 1 if it exists, we can concentrate on factoring. So step number 4 then is write the factors. So you'll be given something like this, ax squared plus bx plus c. And now you're going to write the factors. And you would literally just, this is the way that I would do it. And again, if I'm the math pro here, you're going to kind of follow my lead and see inside my mind. You'd literally write what I've written here. Open parentheses with an x here, open parentheses with an x here. Or a pair of parentheses, I guess, here. A pair of parentheses here, a pair of parentheses here with an x, and we'll fill in the numbers. We'll fill in a sign, and we'll fill in a number. We'll fill in a sign and a number. So how do we determine what the signs are and what the numbers are? Well, the signs are right here. Here's step number 5. You take a look at your c that you've been given. If c is positive, that means that we've multiplied the things together. We've multiplied that number times that number to get that c. If that c is positive, then we know that either both of these are positive, either that one is positive and that one is positive. We multiply these together to get a positive number, or both of these numbers are negative. Negative times a negative would give us a positive as well. So if c is positive, then either it's x plus times x plus, or x minus times x minus. If c is negative, and again, this is summarized also in the book, by the way. If c is negative, then you've either got you've got really one case, x plus something times x minus something, because a positive times a negative number, when you FOIL this out, the last number, this is going to be the last, FOIL, this will be the last number to multiply, or the last pair of terms to multiply. Positive times a negative would give us that negative number if c is negative. So there's something to kind of help you remember what the signs are. And then as far as the numbers go, we've got to find a pair of numbers for ax squared plus bx plus c. And remember, for this situation, we've got a is equal to 1, such that the sum is b. Those two numbers add up to b, and multiply together to give us c. The product of those two numbers is c. So let's try some examples. And you might want to reflect back on this, or write some of these down as well. If I could do this, I could put my smartboard into a dual page display, but then it gets too big for my display, so I can't do it, unfortunately. But you might want to write these down, maybe see if you can print one out. Alright, so let's try an example. Alright, step number 1, remember, was, let's go back. So here's our example. We're going to start with this one here. Start with this example here. x squared minus 15x plus 50. All right, step number 1 and 2 and 3. 1 is write the trinomial in descending order, and then 2 is factor out any factor that's common to all terms. So let's take a look at factoring out any factor that's common to all terms. Well, here's an x squared, and there's an x here, but there's no x here, so we can't factor out an x. We can't factor out a number because there's nothing common with all of them. Step number 2, I guess, was write it in descending order. I think 1 was to write it in descending order. There's 2, and then 1, and then 0. Great. And then step 2 was factor out a common term. No common terms, so we can't factor anything out to make our life easier. Step number 3 is factor out a -1. There's no -1 here. It's not a negative x squared, so it's step number 1, 2, and 3 are pretty much done for us as it's been given to us. So step number 4 is write the factors, because we're going to, again, try to factor this out. So write the factors x and x, which I did already here. So there's my two factors. I know it's going to be x, and then there's a sign here and a number here, and a sign here and a number here. And we'll have to just figure out the sign. So now we have to go back and say, we figured out the signs, that if this is positive, then both of these numbers, both of these signs have to be, actually both of the numbers, have to be either both positive or both negative. Because if they're both positive, they'd multiply together to give us 50. Or sorry, if they were both positive, they would multiply together to give us a positive number. If they're both negative, then they'd both also give us, multiplied together, negative times a negative would give us a positive, and that would be important. So how do you determine that? Are they both positive or are they both negative? Well, this one is our sum. The negative 15 is going to be our sum, so our sum down here is going to be negative 15. They have to add up to negative number, or a negative number, so the sign here has to be both negative, because negative times a negative is going to be positive. Negative plus a negative is going to give us a negative here. So there's our sum is equal to, so now we've kind of put our signs in, and now we have to figure out what the two numbers are. So let's go back here and kind of refresh. Find the pair of numbers such that the sum of those two numbers is b and the product is c. Alright, so we can go through, probably the easiest way to go would be to start with our product and say, well, the product is 50 and they both have to be negative. So let's start with the products. -1 times -50. And that would give us a product of 50. Would it give us a sum of -15? Well, -50 plus -1 is -51. So we throw that one away and we go to the next one. How about -2 and -25? Adds up to -27, not -15. All right, we'll keep going. -3, does 3 go into that? No. 4 does not go in. 5, how about -5 times -10? -5 times -10 gives us 50, a positive 50. What does it add up to? A -10 plus a -5 is -15. And sure enough, that's our sum. So there's our pair that we're looking for. That's the magic number. So the two numbers that we put in there would be -5 and -10. And we can double check our work now and say, well, I tell you what happens if I take x minus 5 times x minus 10. We've got to FOIL it out, use that dreaded F word. First outside, inside last, we go x times x gives us x squared. Outside is x times -10, which is -10x. Inside is -5 times x, which is -5x. Last is -5 times -10, which is a positive 50. Combine the like terms and we get x squared minus 15x plus 50, which is what we started with here. So there's our correct factorization. Alright, so now I'm going to invite you, probably tell you, to go ahead and pause the video now, go through this idea as well. Here's a z squared minus 16z plus 48. And sometimes, you know what, sometimes these can jump out at you. If they don't jump out at you, then follow those rules of make your life easy. Step number 1, write it in descending order. Step number 2, factor out any greatest common factor from all the terms. Step number 3, and this is on the previous slide, step number 3, factor out a -1 if it's negative. And then step number 4, write the factors. 5, find the signs. 6, find the numbers. So take a look at that, go back if you need, and then come back to this one and we'll go from there. Alright, now that you've had some time to think about it, let's take a look at what we've got here. I'm going to start with blue here, and I'll say, here's my trinomial that we're going to try and factor. And again, with chapter 5, we went from here to here because we multiplied the products together. Just like down here, we FOILed everything out. Chapter 6, we're going to kind of go backwards. We're going to go back and start and give you the product. It's kind of like playing Jeopardy, giving you the answer. Now you got to give me the question. So if I give you the trinomial here, we've got to try and factor it out. So step number 1, write it in descending order. 2, 1, 0. Okay, good. It's in descending order. Step number 2, factor out any greatest common factors to make your life easy. There's no z in this term. There's only z's here. So a greatest common factor would have to have a z in it, but this doesn't have a z. And this only has z's in it, so you can't factor any numbers out either. So we can't factor out any greatest common factor from here. Factor out a -1. This leading term is not negative, so we don't have to worry about factoring out a -1. We'll see some examples for that later on. All right, so now comes the more challenging part. We have to find, I guess step number 4 is write these as we're doing. Step number 5 is find the sign, SIGNs. Now, this sign has to be, because this is positive, these both have to be the same, because either a positive times a positive gives you a positive, or a negative times a negative gives you a positive. Now we have to choose negative or positive. They both have to be negative because they have to add up to this number here. So there's a negative and there's a negative. And now our sum has to be equal to -16. Product has to be equal to 48. We have to find the magic numbers, let's say, that are going to be products that are going to multiply together to get to 48 and add up to -16. So we'll just go through and start with if something jumps, and again, sometimes this is very intuitive, and you can say, oh, I get it, that one, it just jumps out at me. Sometimes not. If it doesn't jump out at you, then start going through this method. So again, if you're logical, you'd have to say, well, let's go -1, -48. -1 times -48 gives me +48. What is the sum? -1 plus -48 is -49, and that's not equal to -16, so throw that one away. All right, what's the next one? -2 goes into 48. How about -2 and 48? -2 times -24. What does that add up to? -26, not equal to 16. -3 goes in there. -3 and -16 multiplies together to get to 48. What's that add up to? -19. That's not -16, but we're getting closer. So -4 times -12. -4 times -12 is +48. What's it add up to? -16. There we go. That should be our product. So again, if this a is equal to 1, we can do this method and plug in -4 and -12. X minus 4 times x minus 12 should be our answer, because these magic numbers were the ones that, number 1, multiplied together to get to 48, added up to -16. So these two are the magic numbers. And let's double check our work. X, and sorry, that should be a Z. That should be a Z, sorry. Let's do it with the Z's. Z minus 4 times Z minus 12. What does that give us? We have to use that dreaded F word. That the only time you can use the F word in math. First term, Z squared. Outside terms, minus 12Z. Inside terms, minus 4Z. Last terms, plus 48. Combine the like terms. We've got Z squared minus 16Z plus 48. Is that what we had? Right there is what we had. So yes, that is a correct factorization right there. All right. Let's go to this one. And you know what? I'm going to leave us with this one. I'm going to say right here, for your homework, because I don't want to keep going and make this too long of a video, here's your homework question. Do this one, factor it out, and see what you can get following the rules. Right back here, 1, 2, and 3, and 4, 5, and 6. 1, 2, 3, 4, 5, 6. All right, so that's the one. Any questions, bring it to class. Make sure to take notes. Make sure you have taken notes. And add that answer to your notes. Take a picture of it, put it in my Dropbox. Any questions, bring them to class. We'll talk to you soon.